Alright, so I want to start by looking at these three triangles and thinking about how you classify triangles by their angles. It looks like a right triangle, and we're going to pretend that it is for this case. So I'm going to make a note that this is a right triangle. This triangle looks like an acute triangle, and the next triangle looks like an obtuse triangle. This is based on the angles that I'm seeing. Okay, so we've already learned on a right triangle that c squared equals a squared plus b squared. So that's true on a right triangle, that c squared equals a squared plus b squared. Okay, now I want you to look at this triangle comparatively, this acute triangle, and look specifically at side C, okay? And compare it to side C on this right triangle. And then I also want you to look at side C on the obtuse triangle and think about which side looks longer. So you should notice that side C on the acute triangle looks smaller than it does on the right triangle. And that makes sense, that if we are opening a smaller angle here, angle C is smaller, side C should also be smaller. We've learned that in the last section that we did. So on an acute triangle, side C is really smaller than what we would expect the hypotenuse to be. And on an obtuse triangle, side C is bigger than what we would expect the hypotenuse to be. Okay, so this first example, example 2, says determine whether the numbers can represent the side lengths of a triangle. So that is the very first part of this question. And this is not something that we learned in this unit, but something that we learned previously. How do you decide whether three numbers can be the sides of a triangle? So think about that for a second. Hopefully you came up with and remembered that you need to take the small number plus the medium number and see if they are bigger than the larger number. So in this case, is 8 plus 9, which is 17, bigger than 10? Yes, 17 is bigger than 10. So we're in good shape so far. This can be the sides of a triangle. So if they can, we want to classify the triangle based on these rules up above. Okay, so we need to take the longest side, which is 10 squared. That would be the hypotenuse if it's a right triangle. Okay, then we want to compare that to 8 squared plus 9 squared. Okay, this is what we would expect the hypotenuse to be if it were a right triangle. So 8 squared plus 9 squared would be 64 plus 81, which is 145. Okay, so that's what we would expect the hypotenuse to be. But the hypotenuse, or the longest side, is really 100. So it's actually shorter than what we would expect to be. And that's in line with this definition up above. So this would be an acute triangle. And the reason I know this is because what I would expect the hypotenuse to be is not what it is. This side C ends up being shorter than the sum of the squares of A and B. Okay, so let's do the same for example B. First thing I need to do is add the small plus the medium and see if it is greater than the large side. This is just to decide if it is actually a triangle. It may not be a triangle. Sometimes it won't be, so you need to double check. 5 plus 7 is 12. 12 is greater than 9, so we're in good shape. This is a triangle. Then I want to set up the longest side squared, so 9 squared, equals the two shorter sides squared and added together. Well, not equals. Let's leave that blank because we're trying to decide what's bigger. Okay, so c squared, this is c squared here, is 81, and we are comparing it to, so I'm leaving a little hole there to write an inequality, 49 plus 25, which is 74. Okay, so how did those compare? Well, this is c squared is greater than the sum of a squared plus b squared. So that makes this triangle obtuse. Okay, so now I'd like you to try on your own problems 1 and 2. Again, remember to check and see if it is a triangle first. Okay, so hopefully on problem 1, you set this up first, small plus medium, is it bigger than the largest side? This is only 22, so this is actually not even a triangle. So that wasn't much work at all. All we had to say was, this isn't a triangle. I can't decide if it's acute, right, or obtuse, because it's just not even a triangle. On the second example, you need to set the biggest side, which is 36, as c, so c squared, and then we're going to compare it to squaring the smaller two sides and adding them together. So 36 squared is 1296, and adding these squares together is 1156. So 1296 is bigger. That's c squared is bigger than what we would expect it to be. So whenever c squared is bigger, it's going to be an obtuse triangle. Okay, the last one, the putting it all together, I'd like you guys to save, and we'll do that as a bit of a warm-up next class. Maybe brainstorm what kind of methods you think would be good to decide if it's a right triangle. You can be creative. You don't have to necessarily use what we just learned, Pythagorean theorem. Maybe you can use a different tool that you're already familiar with and a concept associated with right triangles. So maybe think about that if you have some downtime this weekend and are just thinking about right triangles. You can get ready for next class. All right, thanks for watching.